Please stand. And let's pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Remember, O most gracious Virgin Mary, that never was it known that anyone who fled to thy protection, implored thy help, or sought thine intercession, was left unaided. Inspired by this confidence, I fly unto thee, O Virgin of Virgins, my Lord. To thee do I come, before thee I stand, sinful and sorrowful. O Mother of the Word incarnate, despise not my petitions, but in thy mercy hear and answer me. Amen. In the name of the Father, and the Son, and of the Holy Spirit. By the way, if anybody goes for restroom or a drink or something, make sure you keep this wooden block in here. I'm keeping the door mostly closed to trap what little heat we have in here. They're working on the radiator as we speak. And yes, sir.
Wasn't it a retake day today?
What?
For the test, retake today? You said Tuesday.
Not for local class now.
Oh.
I said it was available starting today. And I was, because yesterday I was doing recess duty. But the retake test is available if anyone wants to take it. Schedule the time with me. After school is best because it has a large portion of time. But if you want to do, I keep forgetting what the first section is. Is this household time or is it activity period? Household. If there's nothing happening in the household, you could do household lunch, or you could do lunch activity period. That would make close in 45 minutes-ish. Talk to me if you need to reschedule that. All right, we are looking at homework 4, C as in Charlie, 1 through 4, 7, 10, and 12. Let's see what you got. Wait a minute, hang on a second.
No.
And 15, yeah, sorry, I forgot to put 15 in there. Yeah, you're right. 15.
I should have asked, but I was like, oh, clearly,
Actually, you did.
wow. Hey, I'm trying.
Tomorrow. Okay, all right.
Based off
And the marker reader.
tips,
No, I don't.
six.
The trees screaming in the
I'm sorry.
Yeah, I get it. I always say that killing trees for math is always.
He's wanting to read it, and I'm like, no. They used to be for math.
Okay, check out your favorite red writing utensil. Let's go through some answers. All right, number 1. Now, number 1, you have 3 separate graphs. It's going to be a little hard to describe, but the current graph in number 1 goes up, then down, then up, then across. The reflection, you notice how it starts below and goes above. It should start above. And should I just draw these? This is absolutely awesome. Yeah. I just have this nightmare version of talking for like 45 minutes and everybody's. Number 1 looks like that. The original graph looks like that. It's 2, 1, 0, 1, 2, 3, 4. So you're starting here. Whoops, right. looks like this. Here's the original. The very first graph we have is negative f of x, which is basically taking, you notice where they put the negative? It's not in the parentheses, it's outside the parentheses. So it's basically reversing, flipping it upside down. So the first one should be like this. No, not far enough over. Sorry. How about this is gonna be, should look like this. The easiest way to do these, if it has negative f of x, refresh my memory. What's another name for f of x? Y. Another name for f of x is y. And another name for y is f of x. When they say negative f of x, they really mean negative y. So they're taking the opposite of y, which is a reflection of the x-axis. Another way to think of it. Take all these points and just make the y opposite. If it's negative 1, make it positive 1. If it's 0, make it negative 0. If it's 1, make it negative 1, and so on. So all the heights should reverse. So if the height were 5, you'd go down to negative 5, and so on. Make sense? B, this is actually kind of fun. Historically, we've never done any absolute values except absolute value of x. What happens when we take the absolute value of a regular graph? Let me show you. It looks like this. Why? Because it used to be this. All the negatives become positive. You plug in f of x, you get an answer. If it's positive, absolute value doesn't care. If it's negative, the absolute value flips it. So just to give you a quick demo on this, you've all seen parabolas at this point. Let's just say we have a parabola. This is like y equals x squared minus 4. Over 1, up 1, over 2, up 4. What happens when you do this? This takes all the answers that are negative, and then makes them positive. It looks like this. Whoops. I'll put the dotted line where it used to be, and then I'll show you what it really is. There's the old parabola. Here's the new parabola. You see what I did? The below part got reflected up. So, no, I haven't even shown you how to do that yet. This makes some pretty cool graphs. If you want to have something that looks like a bouncy ball, absolute values are a really good way to do that. So part B, ta-da. For part C, this is a demo. F of negative x, what did they do? Let me put that into words. What does that mean? Is that a move, resize, or flip? It's a flip, input or output? Input, it's in the parentheses. It's inside the function. That means that you're flipping it over the y-axis. That means everything on this side is going to bounce over here. And everything on this side is going to bounce over to here. So it looks like this. Got swiveled. This -3, -1 got bounced to +3, -1. They took all the opposite x's. Does that kind of make sense? This is actually kind of code for opposite x, which means take all the x's and make them opposite. keep all the y's exactly the same. Does that make sense? All right. Number 2, I'm going to try my best to describe this. You're going to take the entire thing and flip it upside down. So there's going to be a little plateau above, then go down, plateau, up, plateau. Does that kind of make sense? For part B, all the places that are below, mirror image them above. So number 2, B should look like this. Something like that. 2C is going to flip over the y-axis. So basically the left-hand side becomes the right, and the right-hand side becomes the left. So if you think of like that red line, that red shape, painted onto a glass pane, take this big long like metal rod on the y-axis and flip it so that you're now looking at the back side. That's what this thing would look like. Does anybody need me to draw it? Does that kind of make sense? If there's any doubt on this, stop me and I'll draw it. Number 3, turn it upside down. So instead of going down curve and then up curve, it's going to go up curve and then down curve. What happens to the absolute value? On the left-hand side, you see where it goes down for that trough? It reflects up and becomes another hill. So it should have 2 hills in a row. And number 3, what happens with f of negative x? The left-hand side and the right-hand side trade, and you're going to have an upward and then a downward. Interestingly enough, number 3a and number 3c should be identical. This should give you the exact same result. Number 4, if it's upside down, you notice there's a hill, then a valley, then a hill. It's flipped over upside down, so it'll be valley, hill, valley. For part B, it should be hill, hill, hill. All the stuff that's underneath, flipped up. For 4C, you should see no difference whatsoever. It should be identical to the original. Because if you flip it left, right, the left hill and the right hill trade places, and you really can't tell. Does that make sense? So that's 1, 2, 3, 4. Skip to number 7. Sketch the graph and then the reflection of the graph on y equals x. Y equals 3x minus 4. I want to talk to you a bit more today about what the heck y equals x is. Y equals 3x, is that minus 4? Yeah. Okay, math people. Oh, Sam, graph that for me.
So the y-intercept is -4.
Y-intercept is -4, good. Okay.
We can go up 3 over 1.
Up 3 over 1, correct. And then draw your line. Now the question is, what would this look like if you reflected the graph over the line y equals x? Oh, math people who remember your reflections. Oh, Mary Claire. How do you reflect over y equals x? Kinda, sorta. Look in your notes if you need to. To reflect over the line y equals x, it's a little weird. It's kind of in code. Switch x and y. Here's how you do it. Let me see. Josh, can you give me the coordinates at this point? 0, -4. Where will its mirror image show up? Over the line y equals x. How do you reflect it over the line y equals x? Back row just told you. Go ahead and look at the notes if you need to. No, that's the first one. X-axis is one of them, and y equals x is way down on the list. How do you reflect over the line y equals x? Go ahead and pick it up. So there are 5 possible ways to reflect that we're studying. X-axis, y-axis, origin, y equals x, y equals negative x. So how do you reflect over the line y equals x? This is something you have to have memorized for the test. For everybody.
Switch them.
Switch x and y. So what would you have?
Also be -4, 0.
-4 comes 0. In other words, you don't have to like do the heavy muscle lifting of the whole line. Do the individual points. The line will come with it. So your new mirror point is here. Can somebody, for example, Nate, give me the coordinates here. 1, -1. Where's its mirror image? -1, 1. Once you have the mirror image points, you can draw it and you're done. Actually, I do that one badly. If you draw your stuff correctly, the regular line and the mirror image should cross exactly on the line y equals x. So this should be the solution for number 7. Can you give me an equation of the reflected graph? Can somebody give me an equation for this monster here? Slope-intercept form would be a challenge because I have no idea what the y-intercept is. Let's do a little algebra. Nick, assuming you only have these 2 points, -4, 0, just out in the middle of nowhere, and then -1, 1. How do you find the equation?
But it comes out y2 minus y1.
That'll find the what?
X in the second one.
That finds the what?
Slope.
Slope. That's a good idea. Do it. You can probably do rise and run if you want. How much does it rise going from here to here?
1.
1. How much does it run?
3.
3. Slope is 1/3. Good. So what's y-intercept? I don't know. I would not use slope-intercept form yet. I would actually use what form? Yeah. Point slope would be good. Which point you want to use? Totally up to you.
-1, 1.
Sure. Do it.
Y minus 1
Uh-huh.
equals 1/3 of these x plus 1 or minus 1.
X minus -1, I'll do +1, just for giggles. That's okay. I'll accept that. I do want to show you something which is kind of neat, and it will save you an amazing amount of time. And it's actually going to spill into our topic today. I'm going to distribute this just for fun. Y minus 1 equals 1/3 x plus 1/3. And we add 1. Y equals 1/3 x plus 4/3. Now, that's why we couldn't do it on our own. I was like 1/4 e. Watch. I'm going to do something mysterious. I'm going to multiply everything by 3. Why? Because I'm mysterious. Because I haven't told you yet. Hocus pocus. Presto changeo. And now I'm going to get x by itself. Why? Because I'm being mysterious. Because I have no idea why I'm. Subtract 4 from both sides. Just out of curiosity, does anybody notice anything? This is the exact same equation as this, just swept up. I'm just going to leave it there for a second. See if anybody notices anything. Go.
Because y is equal to x, you just flip the x and the y.
Does anybody see a really, really fast way to get the reflection of a y equals x equation? Trade the x and y. Done. Now you may have to get y by itself for the poor slobs who have to graph it, but make sense? Any equation, if you want to reflect it of a y equals x, flip the x and y physically. Not just the points, that's helpful for the graph, but in the equation. That'll give you the new equation. And it'll give it to you very quickly. You don't have to go through all this monkey business, which was fun. It was good exercise if you're in the mood. I'm not sure I'm in the mood. Does this make sense? All right, that's number 7. What else? Did I give you number 10? Yeah, y equals x squared plus 3x. This is going to be totally fun. I want to see if anybody can do the shortcut. They want the new graph and the new equation. here's number 10, here's the old equation. Y equals x squared plus 3x. There. I want it over the line y equals x. And somebody give me the new equation without even stressing, without doing any extra work. Mary.
X equals y squared plus 3y.
Got it. X equals y squared plus 3y. Now that's an incredibly weird equation, but they didn't say to make it non-weird. You're done. I'm perfectly okay with that. That's your equation. Now how do you graph it? You tell me, oh math people, we just had a chapter test on this. What shape is it? Renee, what kind of shape did this creature give you? It's a parabola. How do you know that? Yeah, degree of 2. If it's a parabola, what points can you graph on this thing? Wide open question. How do you find them? Like, how do you graph a parabola? There are like 3 different ways you could do it at least. Are there any interesting points you can find? Austin, how do you graph this thing? Give me any way to get any points whatsoever.
And then you can put like 0, 0, get these or something like that, or,
Say again, I'm sorry?
well,
What?
well, I mean, one of the things I did is I like just put 0, 0 in just to get 1 point.
Okay, if you get 1 point, by the way, if you plug in x equals 0, you will get y equals 0. By the way, what use is it plugging in x equals 0? It does have some use. What does that give you automatically? If x equals 0, what have you just found? Oh, math people who remember your chubby hand method, good. That's the y-intercept. So how do you find x-intercepts? Josh? Plug in 0 for y, which is kind of interesting. If you want to get x-intercepts, actually I'm going to have you solve this here, Josh. 0 equals x squared plus 3x. Go for it. I'm sorry? That's one of them. I can't solve it with algebra because there's 2 different species of x. What can we do? There are 4 methods for solving quadratics. Algebra, factoring and zero product property, complete the square, quadratic formula. Which method would you like? Can't use algebra. You can use the quadratic formula. There's actually an easier method. Quadratic formula does work on this, by the way. It does factor. How? What's that? Take out an x, GCF. It's the greatest common factor of x. I decided, wait just a second. And then what's left behind? Go ahead. Right. Can you tell me what the solutions are just by looking at that? Yep. X equals -3 and x equals 0. Now we'll tell you a little bit. -3 is an x-intercept, and 0 is an x-intercept. Can anybody tell me anything else about this thing? Anything at all? Go.
The axis of symmetry.
Axis of symmetry must be where?
Well,
In the middle. Where is it? This is -3. This is 0.
I just did -b over 2, right?
Oh, right. This is, by the way, plus 0. So this is A, B, C. Go ahead.
-3 over 1, so -3.
-3 over 2A.
So 2.
-3 over 2. -1.5. Which, by the way, agrees with our graph. The axis of symmetry of a parabola is always halfway between the roots, halfway between the x-intercepts. So this is going to be x equals -3 over 2. Somebody tell me, is this parabola opening upward or opening downward? Okay. Is this an upward parabola or a downward parabola? Say again? Up. Yeah, why do you say that? There are no negatives. would this be opening up or down?
Sorry?
If I changed it, I'm not really going to, but if I change that now, which way is it opening? Still up, why? Yeah, this, say again, I'm sorry? Ah, height multiplier, there's the magic word. If the height multiplier is positive, that determines if it's going up or going down. The other stuff could be as negative as the day is long, but if the height multiplier is negative, that sends it downward. So this thing must be going upward. So take over, Nate. Does that mean that the vertex has to be above or below 0? Up. Which one? Below, correct. If it's going up, it's got to be below. Find it. Tell me how. Okay, I have one value already. Which number do we have already with the vertex? Go. We have the x. That's how far over it is. -3/2. Can somebody find the y for me? Mary, help me out. How do you find the y? Plug, yeah, not in the weird one, but in here. Yeah, plug it in the original equation. So it's going to be y equals -3/2 parentheses squared plus 3 times -3/2. I'll just turbo this real fast. This is going to be 9/4 plus -9/2. I need a common denominator, so it's going to be -18/4. It's going to be -9/4 by the time we're done. Now, we've got our problem. That's the original. Graph the one that's flipped over y equals x. In other words, graph this thing. Doesn't that sound horrible? It's like this is like you can't seriously be asking Mr. Gaga. No, I will end it all if you should. No, please don't. By the way, there's a very, very fast way to do it, and it doesn't take any hard work. Can somebody tell me the coordinates of this point? Megan, take her. What comma what? Other way around. It's on the x-axis. Yeah, this one. Oh, I see what you're doing. Yeah. What's the original one? -3, 0. What's the new one? 0, -3. See what I did, everybody? I mirror imaged. Can somebody give me this point? Chaley, help me out. Where is that? Right. Where's the new point? -9/4, -3/2. -9/4 is a little over 2 1/4, and then -3/2 is like 1 1/2. That's like here. Sam, Merry Christmas. Where's this? What are the coordinates of that point?
Oh, is that 1?
This is 1. It's even better. This is the y-intercept, the y-axis.
Oh, 0.
It's 0, comma 0. Where's the new point?
0, 0.
You're welcome. The new point is 0, 0. Here's your new graph. Bravo's going sideways. Would not have known that, but we have a quick trick. Remember, to get the reflection of a y equals x, you trade the x and y. You can do it in the equation to get a new equation, and you can do it with the points to get a new graph. So whichever is easiest. I mean, if you flip the x and y and I say, oh, that's easy to graph, okay, knock yourself out. Usually it isn't. When you switch x and y, you usually get a disaster area for something. And then it's harder to graph. Just switch the points, the individual points, and then draw the new graph. Does that make sense? Number 10 is good. Number 12. Y equals radical x. Towel. I think we're done with the zigzaggy. I think we're done with this too, I hope. I want to reflect over the line y equals x. Sorry. Austin, help me out. What's the new equation?
X equals radical y.
X equals radical y, correct. I will tell you right now, that's a little bit more challenging to graph. This one is weird enough. This one is, holy mackerel. Can somebody graph the original one for me? Y equals radical x. It's one of the parent graphs I gave you the other day. Look in your notes if you need.
We just started the origin.
Start at the origin.
Go
Over 1 up 1.
then over 4 up 2.
Over 4 up 2, and so far. So forth. Wow. There's your graph. It's the upper part of a sideways parabola. Can somebody tell me what the new graph looks like? Mary Claire, take that one. How do you find the new graph? Step me through it. Yeah, so what's the first point? Yeah, that's nice. 0, 0 switches to 0, 0. And then, yeah, 1, 1 switches to 1, 1. It's looking pretty identical so far. Give me the next one. Yeah, 4, 2 goes to 2, 4. Can anybody guess where this thing's going? Josh, what would you draw?
Just line them up.
Sorry?
Line them up.
A line?
Oh, yeah.
Like this?
Curved line.
A curved line is kind of a contradiction in terms, but in geometry, what shape? What does this look like?
It's like half the
Half a parabola. That's exactly what this is going to be. It's half a parabola going in another direction. Make sure that the new shape is similar to the old shape. If you have something like a, ziggy-zaggy whatever that doesn't look like this, start over. Does that make sense? That's all you have to do. Switch the x's and y's in the formula, switch the x's and y's in the graph, and then just use common sense to fill in the rest. That was number 12. 15. Test each of these to see if they have symmetry in the x-axis, y-axis, y equals x, and origin. They forgot y equals negative x, but what do you do? 15a, let me read off the answers. 15a, it only has symmetry on the origin. 15a, it only has symmetry on the origin. 15b, it has every single symmetry you could like. First, second, third, fourth. And C, it has symmetry on the origin, and that's it. And it repeats on the whole thing. Questions? Now's a good time to ask. 2C. Oh, okay. Y equals f of negative x for that ziggy-zaggy one. Yeah, let me draw that. The original graph, left to right 5-ish. Okay. So I'm going to recreate the original graph. It's going to be one. No, I take that back. And then it goes up to a peak here, goes over, back down, that's. So here's your graph. If you can identify the individual points, the vertices, the graph becomes easier. So here's f of x. And I want to turn it into f of negative x. Visually, there's a hint. They're taking the opposite x. So here's what you do. All these points, the x is going to flip. This is negative 2, negative 1. This is negative 1, negative 1. Oh, sorry, this is negative 3. What am I doing? So negative 3, negative 1, negative 2, negative 1, negative 1, 0, 0, 1, 1, 1, 2, 0, 3, 4, 5, 1. Those are the points we know. With a little practice, you can probably just freehand some of these sketches, but for right now, let's stay slow and careful. This is going to reflect over here. The only thing that's going to happen is the x is going to reflect. It's going to go to 3, 1. That's all I know. It just basically bounced over here. -2, -1 is going to go to +2, -1. The y stays the same. -1, 0 becomes 1, 0. 0, 1 becomes -0, 1, which is the exact thing. 1, 1 becomes -1, 1. 2, 0 becomes -2, 0. 3, -1 becomes -3, -1. And so on. Here's your new graph. It looks very similar to the first one, except you notice this one has the sort of patio going to the right. This has the patio going to the left. Does that make sense? I just made up it being a patio. Does that make sense? Any others you want to see? Or got a second? How are you on testing the symmetries? Okay on that? Like at number 15? Any questions on that? If there are no questions, I'll assume I can throw any of those on the test and you'll knock them out of the park. Which is very possible. Nobody? Going once, twice. Sold. All right. Take out your notes, please. I want to talk just a teeny weeny bit. I want to try and wrap this up in about 4 minutes so I can give you at least 10 minutes to work. I want to talk about 3 different types of functions. There's lots of different ways to categorize functions. By degree, by positive or negative. I might even have covered this last year, I have no idea. You'll have to tell me if you remember if you remember this story problem I give to illustrate this. Even functions, odd functions, and neither. Now, part of this may be review, and part of this I'm going to tie into our new topic. What is an even function? An even function by definition is this. If you try and plug in a negative input, it'll give you the exact same thing as if you plugged in the positive input. I'll give you a metaphor for that in a second. An odd function by definition is if you try and plug in a negative, the answer goes negative. You get the opposite of what you'd get if you plugged in a positive. And then neither, you try and plug in a negative, you get an absolute psycho problem that has absolutely nothing to do with the original. For example, I'll give you a metaphor example and then I'll give you a math example. The metaphor example, it's a lot like human temperament. If somebody is even-tempered, let's just pretend for the sake of argument that I'm even-tempered. I try to be. And let's assume, but I'm mathematically even-tempered, like to the infinite degree. No pun intended. Degree. Algebra. Even function. Let's say I have a positive input. Somebody walks up and says, Mr. Conklin, that's a nice suit. Thanks. Everybody else has the same nice suit, but thanks. And then somebody said, Mr. Conklin, somebody just stole your car. That's okay. Even-tempered. Whether I get a positive input or a negative input, I'm nice and even-tempered. I give you the same positive result both times. The same result both times. I'm consistent. Now let's pretend, it's a little scary, but let's pretend I'm odd, which is not hard. And let's pretend positive input. Mr. Conklin, somebody just gave you $50. Oh, it's nice. Mr. Cochran, somebody just slashed her tires. Kill. In other words, negative inputs will make a negative output. That's a very odd-tempered person. Neither. This is where things really start getting fun. Now you notice these are all trying, these are sort of asking, what would happen if I gave this person a negative input? Positive input is no surprise. Everybody's going to be in a pretty good mood. Anybody can be in a good mood if somebody treats them well and everything's going their way and they're rich and powerful and blah, blah, blah. But what happens in adversity? That's the test of character. You can be either even, odd, or neither. Even is sort of the virtuous way of doing things. Odd is the sort of homicidal way of doing things. And the neither is, oh, I do remember doing this last year, because I remember telling you about my favorite comedian. His name is Stephen Wright. He's one of my favorite comedians. He was like Mr. Surreal. He just has these bizarre, out of the middle of nowhere, this, what was it? He would go up to, he has this sort of Einstein-y hair, and he's kind of balding, and he would come up to he'd say, ladies and gentlemen, Mr. Stephen Wright, and he'd go, everybody went nuts, because he's really super popular. And he comes up to the microphone, and he says, thanks. Deadpan to the, and they feel like it's hilarious. Then he starts on his monologue. I just spilled some spot remover. Now I can't find my job. I was living in an apartment on the 40th floor, so I didn't want to walk down all those stairs, so I have a dog, so I decided to exercise my dog by walking on the ledge. People saw me out the window and they said, hey, aren't you afraid of heights? I said, no, not me. I'm afraid of widths. This is the sort of thing he does. He's on YouTube. He's like totally hilarious. There was one other. All right, one more. Sorry. So it's a sort of a twofer. Yeah. Started taking harmonica lessons, practicing playing the harmonica. But the only way I know how to play the harmonica is to get in the car, drive 120 miles an hour, and stick it out the window. The other week, I found another engine and I decided to put it in my car. Now my car has two engines. I can drive 260 miles an hour. The harmonica sounds amazing. Anyway, this is like an hour with this. It's really good. Go look him up, Stephen Wright. And moving on. But this is kind of like the Stephen Wright function. Isn't it like positive? Mr. Cochran, somebody just gave you $50. Oh, nice. Mr. Cochran, somebody just blew up your car. You ever wonder how fast a fish would spin if it were at a 45-degree angle? What? In other words, it has absolutely nothing to do with the original whatsoever. Now, math. There is actually a math point to this. Even function. Just as an example, f of x equals x squared. Let's do a test. Again, any function can give you a positive answer if you plug in a positive input. Well, almost. It's pretty reliable. So let's try this. F of 3. Everybody good says 3 squared? Give me 9. What happens when you try negative 3? What do you get as an answer? Yeah. 9. Negative 3 parentheses squared is still positive 9. You notice how whether you put a positive or negative input in it, it didn't care. It gave you the same answer both ways. That's a dead giveaway for an even function. There are lots of even functions in the world. X squared is an even function. X to the 4th is an even function. X to the 6th, x to the 8th. X squared plus x to the 4th. Do you see a pattern there, by the way? X squared is an even function, x to the 4th is an even function, x to the 10th is an even function.
The even numbers are.
If you have an even power, yeah. And what about this? X cubed. Let's try it. What's up for 3? Oh, math people. Oh, mental math people. Oh, Nate. Answer. 27, good. What the heck? Like a 3 lump 3, that was funny. 27. What's that from -3 while you're at it? -27. You notice, plugging in a negative made a difference. If you made the input negative, it switched the sign of the output as well. Now, try this. F of x equals x cubed plus x squared. See what happens. Let's try f of 3. Now remember, the test for odd and even, you have to do a positive plug-in and a negative plug-in to see if there's a difference. You can't just plug one thing in and say, oh, it must be odd. Like you're guessing. You gotta do one positive and then the negative version. So you could do -5 and 5, you could do -8 and 8. I would not suggest plugging in 0. Why? Because 0 and -0 are same thing. You're plugging in the same thing twice. Calculate this for me, somebody. Nick, go.
36 for the first one.
Yeah, how do you get it?
X to the third,
Yeah, so it's 27 plus,
3 to the third, 9.
yeah, 9, which is?
36.
Yeah, there's your 36. Now what about this one?
Negative 27, and 9,
What do you get?
18,
Almost.
negative 18.
Negative 18. Are these versions of each other or no? Like these are 27 and -27, 9 and 9. Is this the same as this? Is it the opposite of this? No, it's like completely out in the blue. Where'd it come from? That's called a neither function. By the way, I do warn you, if you look up Stephen Wright, like 1 out of every 80 of his jokes are a little off color, so just fast forward. There were a couple of them where I was watching them and then it came halfway through this one particular joke. click, fast forward. So, that is super duper funny. Now, clear on this? The reason I bring it up here I just did a mathematical calculation of my own. I'm afraid on the best day of my life, I would not be able to finish the notes in time. So you got a day off of homework, don't get used to it. Go pass a humanities test or something. But I do have 90 seconds more of notes, so stay with me for this. Even function, when you plug in opposite x, it's the same as if you didn't. Let's tie this in with what we learned about symmetry. Symmetry means if you plug in, or if you make one of the reflections, you get the exact same answer. Can anybody tell me what kind of symmetry an even function would have? Does it have any? Sometimes you can tell by taking the graph. This is y equals x squared. Do you visually see any symmetries? Go. Different word. Y-axis. I guarantee you, every even function on Earth will have y-axis symmetry. Y-axis symmetry is taking opposite x and getting the exact same thing. And that's almost the definition of an even function. Does this have x-axis symmetry? Josh? How do you explain it? If you flip it upside down, would it be the exact same graph? No, it'll look different. So it doesn't have x-axis symmetry. Nate, does it have origin symmetry? No, because that's flipping this way and this way. It'll still look upside down. Sam, does it have symmetry over y equals x? Prove it. Why not?
Changing the x and the y.
Right. Instead of going upward, you're going to be going to the right. Going positive y is now positive x. Yeah, y equals x symmetry is going to goof this up. How about y equals negative x? I'm going to take a guess. If you flip it over this line. No, it's going to be pointing to the left. In other words, the only symmetry even functions have, guaranteed, is y-axis. How about odd function? Oh, fluff cars. All right. Well, that's that. We will continue this tomorrow. The next couple questions I'm going to ask you are, what do odd functions have as symmetry? And I'll tell you right now, neither functions have a symmetry. We have absolutely no clue. We have no clue about anything for this. That'll do it. Please stand. And let us pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Alrighty. See you later. Feel free to leave the door, even though, to go out the door, even though it looks closed. It's not meant to lock you in. It's meant so I don't freeze you. And for Mr. Good doesn't freeze you. Somebody coming back into the sanctuary. And that's it, you don't freeze either. Woo! Where's that? You're welcome. Thank you. Oh, did I turn off the video?
No.
Okay, bye everybody. Go.